Now let's have number 40, wherein a long straight wire carries a current as shown in the diagram. So this is the wire, and there's a current that is keep flowing in, and two electrons move with the velocities that are parallel. So this is the case of parallel, and perpendicular. So this is the case of perpendicular to the current. Determine the direction of the magnetic force. So we have to determine the force experienced by each electron. Now let's start first to draw with the case of letter A, wherein if we have to draw the current, so if this is the wire, and there's a current that's keep on flowing. And so remember that whenever there is a current that keeps flowing on the wire, it will create a magnetic field. So by using your right hand rule, wherein you point out your thumb going here, so this is your thumb, and so the other fingers we're gonna look like this. Okay, so here you would take note that the direction of the magnetic field would gonna go like this. So that is the B field that is being produced. Now, and therefore, if that would be the case, the direction of the magnetic field, this one, the magnetic field produced by the wire, it will create a magnetic field that is into the page. So it will create a magnetic field that will be into the page. Okay? Now, so if that would be the case, and this time we will represent the magnetic field as into the page, so the B field that is into the page, and therefore our index finger will be into the page. Okay, now if we try to imagine the velocity of the electron, so this one is the electron, so that electron is a negative charge and it is moving to the right. So that would be the case for letter A. It is moving to the right. Now here we can take note that the velocity of the electron that is going to the right, and so our thumb will be pointing to the right. Now, this time we are asked for the magnetic force. Now, try to use your right hand rule. So if you're gonna use your right hand rule, the thumb, if you try to look at your right hand rule, go ahead and try it. And so the force, so the force vector, that would be going up. Or better, we can say we have the middle finger. By the way, it's middle finger going up. So the middle finger will gonna go up. But take note, this right hand rule, the right hand rule is applicable for a conventional charge, wherein we are talking about the positive charge. Right? We're talking about the positive charge. Now, if we are talking about electrons, so take note here that we are talking about electron. It is electron. And electron, it has a negative charge. There's a word here, but it is an electron, and therefore it has a negative charge. And so therefore, reverse the force. The force will now be downward. And therefore, this will now be your final answer. The force will be downward. Again, what's the rule here? We get the direction of the magnetic field caused by a current carrying wire. And then after that, we use the right-hand rule. But we are talking about electrons, since right-hand rule is applicable only for positive charges. Since we use electron, we reverse the direction. So the force therefore will be downward. Now let's talk about letter B. For the case of letter B, we will gonna have the same direction of the magnetic field. So let's just copy this. So again, that would be your wire, but this time the direction of the electron. So let me just erase this part. So the direction of the electron is going up. So the electron's direction is going up. So that would be the velocity of the electron. That would be going up. Now, if we will try again to represent it with the right-hand rule. So again, the magnetic field is into the board. And so the index finger will be represented by into the board. And then velocity of the electron, it goes up. And so therefore the thumb will be represented by up. And try to use the right-hand rule. Remember that the right-hand rule applies for the positive charge. But try to use the right-hand rule, and you will see that the force vector will gonna go to the left. And so your middle finger, the middle finger must point to the left. However, again, but it is an electron. So there's like a word, but it is an electron. And therefore, we have to reverse because an electron has a negative charge. And so what will be now our final answer? The force is going to the right. And so this will be our final answer for the case of letter B.